another broadcast of mindyourhealthcast.com. As always, I work to find subjects that are intriguing and enlightening and provoking and challenging, which means you may or may not agree, but when it's all finished, it's up to you to take what I give you and go search it out for yourself and make your own decisions. For today, I've chosen an interesting subject to me that I have been working on and studying and researching for many, many years, the subject of anti-aging or longevity. Now, the two words aren't exactly the same. Anti-aging has to do with how healthy you are aging, meaning you may only live to be 60, but live very healthy until that time. But longevity means really increasing the years that you live. And so really it's a combination of both that we want to consider, because what will allow you or enable you to live very healthy, but at the same time live a long age. Now, as one fellow said, the ideal is to die young at a very old age, meaning your body's still in good shape when you finally die. And I've known of some people like that. I knew a researcher, nutritionist. His name was Dr. Norman Walker. He wrote many, many books on juicing and studied the whole concept of health and longevity and anti-aging for years. And he, the last I found out, lived to about 119. He worked every day, traveled all over the world, wrote books, and was very busy. And finally one night went to bed and didn't wake up the next morning. And so normally that would be the way to expire in the studies around the world of societies that do live long. And there are some that live to 130, 40, and 50. And they work and are busy and work in their garden, walk long distances, and are in good health until finally they just one night don't wake up from going to sleep, which to me, of course, is an ideal way to go. In today's world, most of the people end up suffering and miserable and having all kinds of infirmities and hardly can get around, or in a wheelchair or one of the electronic scooters that they're out now, and they're pulling a tank of oxygen with them and taking a handful of pharmaceuticals every day. Really, I wouldn't call it living, it's kind of surviving. And so what I'm talking about is how can you live healthy up until the time it's time to transit this world. At this point, for sure, it appears that everyone's going to die at some point. The question is when and how your life is up until that time. So I've been intrigued with the whole concept. Many, many years ago, there was a TV series, never made it to the main channels, but was shown on UHF, called The Highlander. And they started out with a pilot movie and then went to a series. And it basically was about a group of Scots that were born way back along the way that were called the Immortals. And the message that they got was that eventually they all had to kill each other off until there was only one left who then would live on forever. But in the meantime, they could not be killed except by another immortal. And so by the process of elimination over the years, they gradually dwindled down until ultimately there would only be two left. And when those two fought it out, the remaining one would be immortal. And it was an interesting story, and it took place, of course, in modern times, and the key player was at that point supposed to be 600 years old. And I'm thinking how nice that would be. Just think of all the things you would have learned and seen, and things you could have bought 600 years ago or whatever and kept for 600 years, how much they would be worth as far as antiques, especially if you could keep them in good shape. So, I mean, there was a lot of implications of what it would mean to live that long. Now, I'm convinced that ultimately, in the early period of time, man had the capability of living between 900 and 1,000 years. Along the way, a lot of things happened that have intervened. There were some genetic changes, maybe deliberately, and here we are down to where we are today. The Dr. C. Norman Shealy, who's done a lot of work with anti-aging, in fact, he wrote a book about, I think, living beyond 100, and he said that as we are right now, and with what we know right now, there's no reason why we couldn't live to 140 or 50. And so, in my mind, of course, I like the 600 to 1,000. I think that's good. And so I've been working on ways and learning everything that's out there about what we can do. So the subject of what I'm going to talk about today is some observations that I have made and learned up to this point. And those are some things that we will want to consider. I already told you the difference between anti-aging and longevity, and that there's a lot of books out there that all offer theories as to why we age. And I'm going to present to you several of the theories and the implications of it. And in the first broadcast, it appears this is going to be 2 broadcasts. In the first broadcast, we're going to be talking more about these theories and what it means that these theories, why they would lead to shortening your life. And as we talk about those, you'll begin to see that some of them interrelate to each other. But some authors, want to kind of make a name for themselves, so they'll pick one of these things and really write it heavily as though this is the whole problem, and if you just take care of that, everything will be great. And of course, I don't believe that that's accurate at all. I think there's a lot of things that are going on. In fact, I'm sure there's a lot of things going on that lead to these kind of problems, meaning that the body is prematurely aging. And the Germans have done a lot of work with it, the Austrians. A lot of work has been done around the world. So the first half we'll be talking about, or this first broadcast, talking about a lot of the concepts and theories of why you would age. And in the second broadcast, we'll be talking about some ways that have been developed to measure where you are in the scale of aging. And also then within that are the implications of some things you can do to improve your health and to live a long time. Now, the problem is that we've been fed some bad information, which is not unusual. Modern medicine is always talking about something called the average life expectancy. Now, right away, when you're talking about expectancy, that means you're talking about a probability. And in the realm of mathematics, that's called a probability equation. And for a probability equation to have much meaning, it has to take into consideration all kinds of variables that could affect the outcome. So many years ago, the medical profession established something called this average life expectancy. And I remember when they first came out with it, they were talking that men could expect to live in their 60s, early 60s, and women in their late 60s. And then over the years, periodically, they'll get on TV and say, well, now the average life expectancy is 68 or 9 for men and 70-some for women, and then it's crept up into the 70s. And so they don't do it every year that they talk about it, but every few years they talk about it. And of course, the implication of that is to make the public think that modern medicine has allowed men to live longer. However, that isn't really true, because that's a life expectancy factor, a probability factor. And when they first calculated it many years ago, there was a skewing factor that was helpful to them, but made the whole concept meaningless. And that was that they did not take into consideration the big 1918 flu epidemic that a lot of people died. In fact, a huge amount of people died. So when you calculated how many people had died in a given period of time, but you did not allow that here was an exception then what it would do, it would skew it to make it look like you would not be able to live as long because of the skewing of all these unusual deaths at this one time. And so the interesting thing about this type of equation is that every year that you go beyond 1918, it looks better. Meaning if you did nothing, this life expectancy factor would look better every year. So over the years, it would gradually look like we were able to expect to live longer, when in fact, all we're doing is just getting enough time involved that the skewing isn't quite so significant in holding the numbers down as far as how long you could live. So in my mind, it's totally meaningless. But it looks good for them. It's good propaganda. And that's about what it's good for. Now, a few years ago, there were two gentlemen from Harvard did a lot of research on aging, and they wrote a book called The Vitality Factor. And what they did is they went back over the years, in fact for 200 years, and every death that they could find documentation of the birth and death, they then from that derived something called an average lifespan. Now this is based on reality, meaning this is how long these people lived. And what was the average lifespan of these people that they were able to document both birth and death. Now the interesting thing is that you probably are wondering now, what is that average lifespan of mankind? And the factor was, barring, because they took into consideration that if you had some big epidemic, you can't count that as an average because that's an unusual event. So when they actually took people who were born, lived, and died and averaged it out, the average lifespan was 85 and has been for the last 200 years. So nothing has changed in terms of lifespan, only in this fudged probability equation that's been used to make it look like people are living longer, when in fact they're not. There were people living over 100. See, this average lifespan was 85, and what that meant was that when they looked at all these deaths, that there was an average that it started to cluster at about 85. That means that a lot of people started dying at around 85. However, there were people that died before that, and there were people who died a long time after that. In fact, there were many people that lived over 100. So 85 seemed to be our cutoff in terms of modern life. But that doesn't mean it can't be changed. This is just what's happened over the last 200 years. But as you probably can guess, the book never got a lot of airing because it would have made the average life expectancy factor that medicine has been propagating pretty worthless. Anyhow, the book is probably still available. I don't know. What I've noticed is over the last several years that books that come out that reveal information that can be kind of contradictory to the current thinking or the current trend that's making a lot of money, they don't like anything that kind of disrupts that. As I mentioned in the last broadcast in AIDS, there's some books disappeared that were talking about the fact that HIV was not the cause of AIDS, or at the very best maybe only a factor, and that the abuse of antibiotics was a big problem, and they didn't like that book out, so it actually got pulled from the publisher, period. So there's a lot of books that I've run into over the years. There was another one that we're going to mention the doctor's name, Hayflick, and he wrote a book called the Hayflick Limit. It was a limit on how long cells can live, normal human cells. And Dr. Hayflick wrote this book about his research, and we'll talk about it a little bit later. But the bottom line is that several years later, there was a second book written called Hayflick Unlimited. And that book has disappeared. I can't find it any place. I have one in my library, but I can't find it because I was telling someone about it, and it seemingly has disappeared also. So it seems that books that come out that contradict or let's say are less than profitable somehow seem to disappear from the market. So if you're lucky enough when it's first released, and which is what I like to do, I haven't been doing it recently as much as I'd like, but I've tended to always peruse the bookstores every week to see what new things are being released, because so many times that happens. A book will come out and then it suddenly will disappear. You can't buy it anymore. So I'd like to see them as they're being released, especially if they're books that deal with some type of controversial information. Okay, so there's one other thing I would like to throw in, and I will throw in. I don't just want to like to do it, I'm going to do it. I have to watch in my speech, proper speech. You don't tell someone I would like to say, you just say it. So anyhow, there is another little blue book called How to Lie with Statistics. And it's not very thick. It's probably about 3/8 of an inch thick, and it's only about that big. But what it's really about is how to read something that is offered as a statistic like this average life expectancy and analyze it and see if it really says what the person showing it to you or presenting it is saying that it says. And there's a lot of things you have to look at, because when you are doing graphs, bar graphs, and all kinds of things, there's ways that you can rearrange the data and or the scale of the graph to make something look like nothing or nothing look like something. And sometimes make nothing look like a great something. And so in that book, it takes you through step by step and shows you some of the tricks that people using statistics will use to try to prove a point that's not really true. Now, one of the biggest examples that I had seen of that, even before I had seen the book. Now, it's been out in a couple, 3 editions, and I hope it's still in the market, but it kind of disappeared for a while. Nobody could find it, and then another edition came out. But it seems to me they removed one of the examples from the original book that had to do with the medical field. And he was giving this as an example to show how you could falsify statistics. But anyhow, where I saw that it was done was in the realm of immunizations. And we haven't done our presentation on immunizations yet, but what you can do is you can alter the vertical axis of a bar graph in such a way that it looks like you've done something when in fact you have done little or nothing. And in particular, I'm talking about cases like measles and some of these things. If you actually look at the real data, you find, for example, that smallpox actually nosedive way back in the 1920s. But the graphs that they show today, the statistical graphs, indicate that it disappeared because of immunizations. But the fact is they didn't have massive immunizations going on in the early 1920s that would have caused it to disappear. And so it was disappearing. They jumped on the bandwagon to make it look like they made it disappear with the immunizations. They did the same thing with red measles, which bottomed out in about 1941 or 1942. But they weren't doing mass immunizations for measles in 1941 and 1942. Yet, when they show the graph, it makes it look like the immunizations reduced it. So you have to learn how to look at these statistics, and part of my purpose in all these broadcasts is to educate you and give you tools where you can look for yourself. And you don't have to take my word for it, you go look for yourself. So it's a very good little book called How to Lie with Statistics, and they're not wanting you to lie with statistics, they're wanting you to recognize the lies that are done with statistics. It's a tremendously good book to read, and it will give you some insight in how to look at a graph and say, okay, does that really say that? And it also shows you how you can alter something that will make it look like, as I say, nothing is something. Okay, so now we're ready to talk about some theories of aging. What you're going to find, as I said, these interact with each other. it appears that they don't all stand alone. If you're talking about one thing, you already can see how it can affect something else. For example, we'll be talking about toxicity, and you will see that the mitochondrial decline, either in number or function, is a problem in aging. However, one of the reasons why the mitochondrial decline is because of toxicity in the body. So they kind of all tie together in many respects. However, the people who kind of advocate these different reasons why we age, if that becomes their hobby, they kind of tell you, yeah, this is what happens, but they don't tell you necessarily why it's happening. And that's what we really want to look at, is to why this is going on. So as we look at these things, you will find them interesting, and you will find that when you hear what the problem is, you right away can almost surmise what would be the way to counter that, because it's inherent within it. For example, the first one we're going to talk about, you'll see that inherent within the problem is the solution as to how you deal with it. So you'll be able to figure out some of it yourself, but as we get into the second half, we're going to talk about the different ways that we can monitor how fast you're aging and in what areas you're aging, and then what we might be able to do about it. So the first one is called the problem of ROTS, R-O-T-S, sometimes referred to as human rust. And ROTS stands for reactive oxygen toxic species. Some people just call it reactive oxygen species, or ROS. I know Dr. Bradford is a big researcher, biochemist, and he refers to it as ROTS in his material. But what it is basically oxidation, meaning free radical damage. And so as your body is exposed to oxygen in various forms, like superoxide radicals or oxidized molecules, those are the things that have to do with damaging cells. And damages internal structure of the cells. It can damage cell membranes, and we're going to talk about membranes in a minute. So these reactive oxygen species, or toxic species, or rust, body rust, is one of the things that increases or accelerates the aging process. And as we talk about the Hayflick limit a little bit more, you'll see why that could be true. But there's a lot of things you can do in your life to accelerate. Now, if the body has everything it needs, you're going to find that a lot of these things would be taken care of if we made sure that our body got what we need in terms of nutrients, food, water, movement, and all these things, and not putting things in your body that are not the best for your particular body. So those could all be a big factor in this whole idea of aging, period. If we did that. Now, years and years ago, when I was young, as I've said before, basically people were healthy unless something unusual happened. Now, in our modern world, it seems that basically you have to work very hard to maintain a basic level of health. It's not a given anymore, whereas it was when I was young. And so when I see that, then I have to say, what has changed that could make that happen? And of course, the things that we're going to be talking about and are talking about are those things that have happened. And now we are being challenged to just be basically healthy, let alone living a long time and living healthy a long time. So all of this is going to work together, because if you're working toward anti-aging longevity in your life, it means you're also going to be working toward putting the body in better shape and keeping it clean, and therefore it's all going to be part of the same package. But it is interesting to see how people have tried to address this. So if you believe that the cause of aging has everything to do with reactive oxygen species, or ROTS, then that's what you would be trying to offset. But offsetting that alone really is not going to do the job. I've studied all the different writers who talk about that, but I would say that's been one of the early big ideas about, okay, here's why you age, and here's what you need to deal with. Now, they're right and they're wrong in my mind. It means they're right because this is a factor, but they're wrong if they think it's the only factor. And so you really have to take them all together, and as I say, as you listen to these, you're probably going to say, oh yeah, well, if that happens, then that's going to affect this other thing. And so there's rarely anything that happens in the body that is standalone. Everything affects everything else. If you study biochemistry and biochemic pathways in the body, you realize that there's long chains of events. In order to get here, you have to do this, plus this, plus this, plus this, plus this, to get this. And this is very important for your body to function right. Well, if you take one of those steps out of that chain, you break that chain, and so all the steps following that break aren't going to operate. They start to shut down. And so the more of your body that happens to, the more your body is going to shut down. So the irony of it is that so many of the things that happen in the body do not immediately show up, and it does not immediately affect you. Sometimes it takes a while for the effects to hit you. And then suddenly one day, bang, you get hit, and you think, well, how did that happen? Well, it happened because for the last several years you've been doing this and this and this, and now suddenly it's making a big enough impact on your body that you now have the results of it. And you know that it's there, but you think it just happened. Oh, well, I just developed this. No, you didn't just develop it. You've been developing it for a long time. I've said it over and over, but I keep emphasizing it because it doesn't seem to stick. When I hear people in conversations, then I know that it's not clicking, that this is happening. And so a disease like Parkinsonism has to do with the destruction of a portion of the brain called the substantia nigra that's a big producer of dopamine, which has to do with coordination of movement so that you can freely move and coordinate your movements together and so forth. Well, that is sensitive to certain chemicals, and they know that because some things have happened, like there's a book called The Case of the Frozen Addicts, and it's an interesting book to read. It's about a young man out in California who decided to make some illegal drugs. I guess he learned just enough about chemistry to decide to make these drugs for him and his friends. So he manufactured this drug, and they all took it, including himself. The problem was that he didn't realize that the process he used, there was a toxic element produced as a consequence of that, which he wasn't aware of and did not have a way to get out because he didn't even know it was there, and that substance ultimately destroyed the substantia nigra in the brain. Now, that only came later, that knowledge, because what happened is these people suddenly went to the emergency room, and here we're talking about young people, 18, 19, 20, 21, show up in the emergency room with advanced Parkinsonism, meaning they're so stiff they can't move, they can't talk, somebody's taken them in and said, I don't know what happened, but they just suddenly can't move, they can't do anything. And of course what had happened is that ultimately in the investigation they found out that this toxic substance in this illegal drug that this young man made was very destructive to the substantia nigra in the brain. Now, the interesting thing about Parkinsonism is that you can have about 70 to 80% of the substantia nigra destroyed before you get the first outward symptoms. Now that means that it's going on a long time, but you don't know that. And it's finally one day when you start to have the first symptoms of Parkinsonism that now 70 to 80% of that tissue has been destroyed. And that's when they found out that it was very sensitive to certain types of organic chemicals. And the problem is then, with modern medical treatment, is instead of working for a way to stop the process and to keep it from progressing any farther in hope that you might be able to have some regeneration, what happens is they give you a substitute of dopamine to fill it in, and that improves your symptoms for a while. The only problem is, in most cases, in 1 to 2 years of continuing substituting the dopamine while the substantia nigra continues to go downhill, suddenly there's a day when that doesn't work anymore. And the person wakes up one morning and can't move, can't talk, can't do anything. And I've seen that happen before. So this whole aging process thing is the same way. These things are happening in your body, but you're not aware of it. If you're not tuned into what can happen and looking for ways to measure it, and number 2, ways to avoid that, then one day you get really caught blindsided, as the commercial was for one of the statin drugs. That worked very effectively. It sold a pile of drugs, but this guy comes on at the beginning of the commercial with his head down, and the video part of it is in gray tone, no color, and he says, I got caught blindsided. And of course then, as they progress with the commercial, once he takes this drug, all of a sudden everything's in color, they're outside, they're enjoying nature, he and the family are all laughing, and everything is great because they took this drug. But anyhow, people do get blindsided with the aging as well as illness. Now, it's really hard to separate aging and illness. All the aging is that it's accelerated aging due to things that have happened to us that we might consider as disease, and maybe we won't. But those are the things that can lead to aging. So this ROTS problem is that you start accumulating these free radicals, and what do free radicals do? Well, we've talked about it a lot, but I guess it doesn't hurt to emphasize it. I found out a long time ago that you can tell somebody something half a dozen times, and still sometimes it hasn't connected yet. And it sometimes has to be presented several different ways until you happen to hit the way that really comes home to the person that you're talking to about it. And so these free radicals, every time you put something in the body that has a missing or a lot of missing electrons, it is looking for electrons. That's the nature of chemistry and the nature of the way things combine or come apart. And when you're missing electrons, you have an unbalanced electrical charge in a molecule and or atom. And so it's looking to fill that void, and the first electron that it comes up on that can be pulled away from where it is, it's going to do that. So if it happens to be in a cell wall, it's going to damage the cell wall by pulling an electron, because once you unbalance another molecule, it doesn't function the way it should. So then you can start some process that is going to shorten the life of a cell by damaging it by oxidation. Now there's exterior oxidation, which means things that get into your body from outside, and there's interior oxidation, such as when you make energy in the cells, a lot of the byproducts that can happen as a result of that energy production are free radicals that can damage the interior of the cell as well as damage the mitochondria that it was generated from. And so consequently, the body, if it is fully nourished and has everything it needs, has what it takes to neutralize that. So then there's no big problem. You can neutralize it and you won't be damaged by it. At least if you are, it's very minimal. So you're looking for two types of reactive oxygen species, those that come from without and those that are generated from within. The body normally has its own repair mechanisms to keep it from happening within if it's properly nourished, if it has what it needs. The ones coming from without, you may sometimes either get away from the source or you may need to take some additional antioxidants to protect. Now, we've talked a lot about antioxidants before, and there's some major ones that most people know about, but I think sometimes forget the importance of. The body has a series of barriers within and without to protect from damage from oxidation. And those antioxidants everybody's familiar with, the one that starts at the skin level is beta-carotene. Beta-carotene protects at the skin level. If you go deeper in the body, you have something that is a layer of membrane that separates the matrix of the body, which is the filler part of the body, from functional cells of the organs. And that's called the basement membrane. The main antioxidant that sets in that is vitamin C, which is a good vitamin C is an electron donor or an antioxidant. Now, of course, today a lot of the C is useless, and it doesn't do it because of the sources that they make it from or the way they handle it in processing. And so if you get a good one, it's loaded with electrons, and it will protect things that have to pass through the basement membrane. If they're oxidizing in nature, it will neutralize them. When you get to the cell wall, you get vitamin E in the cell wall that's protected the cell wall. When you get inside the cell, you've got some different protectors. One happens to be selenium, and the other happens to be glutathione reduced. And those protect the interior part of the cells. And then in and outside the cells, you have a couple of enzymes, one called SOD and one called catalase. And those all work to neutralize. In order to make those, you have to have certain nutrients and certain elements or minerals in the body. So, as I've said so many times, all of this comes together. You have to feed the body properly, have to put the proper things in order to make it work and to live a long, healthy life. And if you do that, you can, in fact, slow down the aging process, and you can, in fact, lengthen life. Now, it's not going to be easy in today's world because every way you turn, and as we talk about more of these, you're going to see, every way we turn, there is a big problem. So, ROTS is, I would say, was probably one of the first and emphasized a lot by a lot of people as being the cause of aging. But it is a cause, a factor, but it's certainly not all. The next one that came about, big, was the membrane. The membrane, of course, is a bilipid layer that surrounds the functional cells, and it allows certain things in and keeps certain things out. Now, if it works properly, then you do a good job. And you also, it has the capacitor-like capability, which means it can store electrons, and it can develop an electropotential between the inside and outside the membrane that helps in the process of keeping the wrong things out and letting the right things in. And that also keeps the cell healthy. And as we talk a little bit further, we'll be talking about body electronics. So those are the things that keep the cell working properly, is to have a good membrane that keeps the wrong things out and the right things in, and allows the body to get rid of toxic byproducts of metabolism and takes it outside the cell. If you disrupt the membrane, which can happen from what we were just talking about, the ROTS in the body, the oxidizers can do that. But the other thing is, in our world today, is that the fatty acid problem. Ever since they got on the kick about saturated fats and cholesterol and developed a multi-billion-dollar industry, both within the food processing industry and the pharmaceutical industry, they've played on this idea. They talked people into eating huge amounts of polyunsaturated oils, and many of them were damaged in the process of the way they made them. And then they lied about margarine being polyunsaturated, when in order to make it stay solid at room temperature, it has to become saturated. And so they artificially saturate it by putting it in a big vat and throwing some nickel filings in it and stirring that all up. And what that does is it saturates the binding sites, and you end up getting some oxygen in, and the heat can cause the molecule to change and become a transform instead of a cis form of fatty acid. And so then you are taking huge amounts of damaged, oxidized, and trans fatty acids into your body. Now, if your body has to have fatty acids to build a cell wall, then guess what? It has to have good fatty acids. I believe that many times fatty acids are not given the due consideration that they should have. We just kind of think, well, they're oils and fats, and we put them in, and then we've been told by medicine for many years, as long as you stay away from those terrible saturated fats, that everything's going to be fine. Interestingly, the other extreme is that the doctors who do organ transplants many times tell their patient to eat lots of polyunsaturated oils because they depress the immune system. So it's kind of interesting, depending on which side you're wanting to utilize it, how you tell the story about them. But I say in all cases, large amounts of polyunsaturated oils are not good, even if they're good, organic, healthy ones. Well, most of our oils are better if they're actually as part of the food. It doesn't hurt to use some, but and some real butter, which I've always advocated. This whole thing of cholesterol, as we've covered, is a farce, and if you have investigated it, you would have found that out by now. And if you disagree, then that's perfectly fine too. That's up to you. Anyhow, the cell walls are a double layer of fatty acids, and they have the capability of generating an electrical charge between the inside and outside, which helps keep the good things in and the bad things out, and keeps the cell functioning healthy. Now, if you read Dr. Bruce Lipton's book, The Biology of Belief, you'll find that he's a cell biologist, etc., and has a PhD, has taught in medical schools, and has now become popular because of some of the material he's written. But he says that the cell membrane really is controller of cell function. Everybody always started thinking from the time they started talking about DNA that was the brain of the cell. The DNA is a library of information that's utilized to synthesize proteins, but it does not direct the cell. It doesn't tell the cell what to do. It waits for messages to come to it, even tell when to replicate or build new proteins. It's the actual cell membrane that controls what can get in and not get in the cell, and directs second messages that come to the outside to carry on different functions in the cell. So that means that the cell membrane has to be of high integrity, made out of good material. If it is not, it can leak the electrons, or if it's been oxidized, it can leak, and therefore it cannot store this electrical charge. Which is extremely important in anti-aging and longevity, is that the cells have a high electrical charge. Now, normally that's about 80 to 120 millivolts on that membrane. And the membrane has to act like a capacitor. And I don't know if you know what a capacitor is, but a capacitor is two conductive plates separated by a dielectric, which is something that will not allow electrons to move from one plate to the other. So it's holding a charge. It can act like a battery. And so you need the cell membrane potential to make it work right. And if you disturb that membrane, then it can't hold a charge. And that if the membrane potential, which should be 80 to 120, drops down to about 45, the cell can become a mutant cell, which can be then a malignant cell. And then if it drops down further, they can replicate. So malignant cells drop the voltage by expanding the cell, and when it hits about 25 millivolts, it will separate and build another cell. And so it can do that very rapidly. So you don't want that to happen. You want a high membrane potential. And to keep that working, you have to have a good capacitor around the cell, which is the cell membrane, the bilipid layer. So if the problem is, if the body does not have good fats, it's going to build the cell membranes out of bad fats. And the bad fats don't work right. So now you've got a problem. And so that's why some people have said, well, that's why you age, is because the cell membranes become disturbed and or become made out of bad oils and fats until finally they don't work right. And so you age very rapidly and go downhill rapidly. So that's, that is true to a degree, that will happen. And it can be a bad problem. Now, when we talk later about some of the ways you can monitor, there is in fact a test that will tell you about the integrity of the cell membranes. Now, the good news is if your body gets good fats, it will displace the bad fats with the good fats because that's what it really wants. And that means you can have a corrective action by taking in the proper fats, which would mean a good like organic flaxseed oil or good fish oil that's not contaminated with a bunch of garbage, and or as the one that the pharmaceuticals put out. Now, you know, talk about strange things. What happened in this country is that the regular medical researchers found that fish oil worked equal to or better than the blood thinners that the pharmaceuticals were selling, and they even published studies in the New England Journal of Medicine and in the Journal of the American Medical Association, so it couldn't be denied any longer. Okay, so the pharmaceuticals realized that people were going to buy these oils. Now, they're not really happy about you buying good oils because there's a problem there. That means you're probably less likely to get as sick and therefore want to buy their other garbage. So, consequently, they decided to come out with their own fish oil. And I don't have good feelings about the sources they may be using because, as you probably know, there's a lot of mercury contamination and a lot of other factors that could be in fish oil if it's not proper and doesn't come from the best sources. And see, some of the companies that I know in the natural health field, if they purchase an oil from fish oil from some producer, they then go to their lab and test it for contaminants and all kinds of things before they will accept it to actually use it. And if they reject it, guess what? Somebody's going to buy it and put it out on the market because they can sell it cheap because of the fact it was not a good oil. Well, anyhow, I don't know what the pharmaceuticals are using, so I cannot attest to that. But I do know this. If you read the label, it's interesting because it's not pure fish oil. It's diluted. And guess what they dilute it with? Polyunsaturated vegetable oil, which actually works contrary. It's probably oxidized, number one, which means it's going to damage the fatty acid. And number two, it's probably transformed fatty acids on top of it, which are damaging to the body as they get in the body and are immunosuppressive. So anyhow, they're selling it. Now, a bottle of these capsules of this fish oil, which they're selling, we probably sell, and I know the one that I would have is a high grade because I know the companies who do it, for $20-some for like 90 or 100 gel capsules of the fish oil. Well, the pharmaceutical sells 90 to 100 of the gel fish oil diluted with vegetable oil, and they sell it for $180 to $280 a bottle by prescription. So to me it's kind of interesting. They knew the market was there, they knew the people were buying it, they knew the research said that the fish oil was good, so they're going to jump on the bandwagon and sell it. Unfortunately, as I say, I picked up one of them and I looked at the label and it said it was actually cut with polyunsaturated vegetable oil. So to me, whatever good effect you would have gotten from the fish oil, it's been ruined by having added this polyunsaturated oil to it. And of course, they're charging an outlandish price. If you're talking $180 to $280 a bottle compared to $20-some a bottle, you know that it's robbery. Now, I've said it before, and I'll say it again. In my opinion, the pharmaceutical companies don't really care what you take. It really doesn't make a bit of difference. The only thing about it is they want to make the big money on it. That's all. As long as they're making a big profit, they don't really care what you take, whether it's vitamins. You know, for years they opposed vitamins, and then all of a sudden, when it became evident that people were going to buy them anyhow, what do? They come out with what I call a cheap synthetic version of vitamins and act as though, well, sure, everybody knows you should take vitamins, when for years they were saying you're expending all the money for nothing, you're creating expensive urine, they're not worth it, you don't need it, all you need to do is eat a good balanced diet. And of course I heard a doctor from the University of Miami Medical School quoted on the press saying a cheeseburger, French fries, and milkshake from McDonald's was a good balanced meal. So, anyhow, you draw your own conclusions about that. So the membrane can be a problem, but you know, if you want to find out more about it, I would read the book by Bruce Lipton called The Biology of Belief, and he talks about the importance of the cell membrane and actually how it operates like an electronic semiconductor or transistor in the body, and that acts as the brain to regulate how the cells function. So obviously, if that gets damaged, you've got a problem, and as I say, one of the tests that we're going to be telling you about will actually measure the potential, actually the capability of the cells in the body holding an electrical potential. It's called parallel capacitance. And if that number is low, that tells you you've got defective cell membranes. And to me is a very good indicator of your aging way too fast. And so that's one of the ways that you can help calculate where you are in the aging process. Okay, one of the other big ideas or theories was the mitochondrial idea of the mitochondria either becoming damaged or dying, one of the two. You know, all the cells in the body have little organelles called mitochondria. Some of the cells, like some of the fat cells, only have a few dozen, or if that. However, some of the muscle cells, like the heart cells, can have 500 or 600, 700 mitochondria, maybe even more. And so those are little units or organelles within the cell that produce energy. And that energy is what keeps everything going. And if those aren't working right, you don't have much body energy. You can't repair your body. Your immune system is weakened. And of course, the cells are going to die off faster. And what does that mean? Of course, it means you're aging faster and you're also shortening your life. So I can see why mitochondria might be considered as a big player, and it is. However, when we talk about some of the other things like toxicity, well, toxicity is what can get in and make a problem with the mitochondria. We mentioned about the antioxidants and the oxidation. That can damage the mitochondria. So there's other things can happen, and we'll be talking in toxicity also about certain medications and chemicals from the environment that we get in can interfere with the production of energy. Now, if you understand mitochondria, you know what they do. They take proteins, carbohydrates, and fats, and I mean they can use any of those. They go through a series of biochemical processes that end up in giving you something called acetyl coenzyme A, and that enters into a cycle within the mitochondria called the citric acid cycle, and as it goes through a series of steps, it releases protons and electrons, and finally at a certain point, the products going through that cycle swing off into something called the respiratory chain, and there, in conjunction with oxygen and these other factors, there's a series of steps that build ATP molecules, which are the energy storage molecules in the body. It's called the high energy bond that holds energy like little batteries. And then when your body needs energy, it draws on the ATP, and as that high energy bond breaks and changes adenosine triphosphate back to adenosine diphosphate, energy is released, and that's what the body runs on, except in an emergency when it reverts to a process called glycolysis, which means sugar just is fermented down to make some energy, and it's a different process, an emergency process. And of course it's not great because the lactic acid is produced as a byproduct, which is an irritant to the tissue, and so forth. So we're not getting into all that, but when we talk more about cancer, which we will be talking to, we'll get heavier into that whole concept. But at any rate, we need oxygen, and the oxygen and the nutrients that we need, because there's certain B vitamin factors like riboflavin, certain minerals that are necessary to go through the steps in the Krebs cycle and also the respiratory chain to build this energy. Now, the final byproduct of all of that is what? I don't know if you remember your biochemistry or not, but the end of the respiratory chain, you get two products. One's carbon dioxide and the other is pure water. That is the end result of the respiratory chain making energy in the body. So if that gets damaged in some way, then you're in big trouble because you can't make energy. And so there's been a lot of studies of the mitochondria and what you can do to resuscitate the mitochondria. And there are ways to do that. And when we talk a little later about what you can do about some of this, even where the cells are so damaged, the mitochondria are run way down, like in the heart with the massive, like congestive heart failure, where the heart is literally disintegrating. There's ways to jumpstart the mitochondria to bring energy back up and to rejuvenate the heart. And I've seen it work, so I know it works. It's not just theoretical hearsay, but I know that it does work. So I can see why someone would be led to believe, well, maybe the real issue with aging is mitochondria, because if they're not producing enough energy, then your body, everything starts to slow down and run down. And the cells, instead of replicating, building new cells, are so weak that they may not be able to do that, and so everything begins to fall apart. And in fact, that could be true. And there's another factor with mitochondria is because they are needing things so fast to work, because they need enzymes, and enzymes require protein or amino acid molecules to make proteins. To make it work for the enzymes, then it has its own DNA. And that DNA can become damaged, as we're going to be talking about. And so there's a lot of things can happen to that mitochondria that it doesn't work right. And usually people with chronic fatigue, that's one of the problems. The mitochondria are in a slowdown process. They're not making the energy like they should, so the person really doesn't have the energy to do a lot of things. So the next big thing is toxicity that looks like we're going to be getting into, but it looks like we're also maybe running out of time. So what we will be doing in our next broadcast is we're going to start with toxicity. I better put a big check there. And we'll finish the various factors, which there's not a whole lot more to go, but a few. And then we'll talk about some ways of measuring how fast are you aging. Because there are some ways of doing that. Different people have different ideas about how you do it. But if you take a lot of them together, you can start to get a pretty good picture of where the body is in terms of disintegration. And then we will be talking about a rationale for correcting that and to live a long time. Now, we may not tell you everything you need to know, because there's some things that are still, in my mind, highly investigated for me, so I don't want to throw it out yet. But there's some other interesting things that I've run across at some part way down the road, maybe. We'll get into some of those things. So it was nice to talk to you again and work on giving you some tidbits that may be useful for your life, to give you health and happiness. Don't forget to go to our website, mindyourhealthcast.com. From there, there's several kinds of pages, all kinds of information related to health there, and some products that we put there, as well as the books that we list there that we talk about. And you can click directly to the broadcast, as I'm sure you know by now, from there. And you can click to our alternative health and prevention website, which talks more about the office and some of the things I do at the office. And also, you can go directly to this broadcast, as you know, by going to freedomcast.com/mindyourhealthcast. Otherwise, be sure and tell a lot of people about the broadcast, and be sure to post any questions that you have. We have a forum sheet. You can go there and ask questions, make comments, criticisms, or whatever you want to say. And if you give me some good ideas about what you would like to have me talk about, I'll be happy to see what I can do about putting something together. So it's time to say adieu again to our next broadcast, and we will complete our discussion on observations on anti-aging and longevity.